Hi everybody, I'm Greg Fishel. Welcome to I don't know if I should call it a special bonus weather video because it's really a makeup for Friday when I was having technical problems with my Mac, and they're all straightened out now, but I felt like I shortchanged you a little bit, and so this is the makeup for that, and we'll have our normal 3 bonus weather videos this week on Tuesday, Wednesday, and Friday. So just wanted to reassure you of that. So going to do a couple of things here today. Number one, we're going to talk about the depth of air masses and how it's affected by mountain ranges. And then number two, I'm going to have a little commentary at the end about how this is something that bugs me about some media elements, if you will tend to hype temperature drops, and they really don't accurately portray what's actually going on and how big it really is. So we'll get to that in just a second. So let's go on ahead and take a look first at this air mass depth issue. Now, this is the 2-meter temperature forecast for tomorrow afternoon at 2 o'clock, and 2 meter is the standard observation height. These are all lines of equal temperature, or isotherms, and you can see that they're really tightly packed here from southeastern Pennsylvania down across western Virginia, right along the North Carolina-Tennessee border, and then down into Louisiana. But basically, this band of tightly packed isotherms is pretty linear, okay? It's basically northeast to southwest. Now, let's go on ahead and take a look at the forecast for 2 p.m. on Tuesday. Okay, move my mouse up here, and there we go. Now, the cool air mass, the shallow cool air, is only a few thousand feet thick. Well, the highest mountains in the Appalachians are in the southern Appalachians, and some of those are 4,000, 5,000, 6,000 feet, okay? So it's very difficult for a shallow cool air mass to get across the mountains. But up to the north, where the air mass has a little bit more depth to it, it can spill across the mountains, and also the mountains aren't quite as high up there. And then once it gets east of the mountains, then it can drain southward, east of the Appalachian Mountains. And this is where we get into these cold air damming scenarios around here, where in the wintertime, once cold air gets into the northeastern U.S., it has a free trip right down east of the Appalachians, and that can create all sorts of precipitation type problems for central North Carolina, at least it used to. So look at these isotherms now. Instead of it being sort of a linear band, notice how it comes down and then it actually curves westward, the isotherms do, and then they curve back toward the south and west. And this is because the mountains down here in southern North Carolina, upstate South Carolina, and northern Georgia are blocking the cool air. So the cool air is not coming in here from the west, okay? It's coming in from the north, and we're having to wait until the cool air gets east of the Appalachians up across Pennsylvania and Virginia, and then it drains southward after that. So let me go back here. Again, instead of it being a straight line like this, now it comes in like this, curves back to the west, and then comes back to the southwest. So there's this little bump right in here, and that's indicative of where the high mountains are blocking the cool air. Then once we get to Wednesday, then the cool air has made it southward, east of the Appalachians, and it's made it eastward across southern Georgia and parts of Florida. And so now that isotherm, and let's take the darkest one here, now it's pretty much straight again. Just a little bit of a bump here across Florida, okay, where the land is heating up more than the water on either side of it. But basically, we're back to a linear pattern again. And so the depth of an air mass is really, really important. And the models used to have a really hard time with this, and they still do to some degree, where they try to bring the cold air in too fast, okay, into central and eastern North Carolina. And it just never happens because of the mountains blocking that shallow, cool air. So we have to wait for it to get east of the mountains, north of us, so it can drain southward. So our cool air is coming in from the north and the northeast and not the west. Okay, I hope that makes a little bit of sense. Now, let's get into this other thing here. A little bit of review, first of all, about what normals mean, okay? Normals are a 30-year average, and they're updated every 10 years, okay? The weather is never what I would call normal, okay? There's natural variability in our weather. Some years are warm, some years are cold. When you average it all out, this is what you get, and somewhere along the line, somebody decided to call it normal, even though the weather is rarely or never normal. The current period that's used is 1991 to 2020, and once we get to 2030, then the normals will be updated and we'll go from 2001 to 2030, okay? The normal high and low for tomorrow quote unquote, is 68 and 45, and the normal high and low for Tuesday is 68 and 44. So normally the temperature drops 24 degrees at night, okay? And you really can sort of use that, as a, I guess, an estimate as to what you would normally expect this time of year is about a 24-degree drop at night. Sometimes a little less, sometimes a little more. Okay, so a little hype, perhaps? No, we can't have that, can we? So after forecasting a high temperature of 85 tomorrow, I'm forecasting a low Tuesday morning of 48, okay? That is a 37-degree drop. But what if you hear something like this on radio or TV or social media saying, get ready for a 37-degree plunge in the temperature tonight? Well, let's consider this. 24 of that 37-degree drop is perfectly normal. That's what you would expect this time of year, okay? So it's only 13 degrees more than what you would normally expect based on the 30-year average. So it's really quite misleading to say, oh, this is incredible, a 37-degree drop. Not really, okay? But what is important, you have to compare apples and apples, okay? Now the high temperature Tuesday, we're forecasting to be 34 degrees colder than the high temperature on Monday. Now that is significant, and there you can say we're expecting a 34-degree drop in temperature because you're comparing a high and a high. You're not comparing a high and a low because the low is always lower than the high by about 24 degrees this time of year. And so it's really sort of an unfair comparison to make. But if you compare low to low or high to high, then it makes perfect sense. And if you've got changes of 30 or 35 degrees from high to high or low to low, then that is worth pointing out and is very, very impressive. All right, folks, that is it for now. That's the bonus weather video for tonight. And we'll have another one coming up for you on Tuesday and Wednesday and Friday, and the next daily weather update, of course, coming up tomorrow afternoon. So hope you have a good rest of your Sunday evening if you're still awake. If not, I hope you're able to watch this in the morning, and we'll talk to you again late tomorrow afternoon. So you all take care, folks, and we'll talk soon. See you later.